Hey folks, in this lecture we're going to start talking about the new topic of arrays. Arrays are a way in which we're able to hold more than one piece of data in a single data type. And so we're going to see how they work, we're going to see how to use them, we're going to see how it works when we're tracing code with an array in it. Alright, so first off, let's talk about the variable types that we've seen so far. So we've talked about that there are 8 primitive types, and 6 of those are related to numbers. We had bytes, shorts, ints, longs, floats, and doubles. All of those can hold numbers of various forms, from small to large, and also from lower precision to higher precision floating point numbers. And then we've also seen characters and booleans, and those together with the 8 primitive types. We've also seen at least one complex data type, which is called a string. And today we're going to see our second complex data type, which will be an array. Each of these ones that you've seen so far is capable of holding one value. So when you create an integer x, it can hold a number 7, or it can hold a number 9, but at any given moment in time, it can only hold one value. If you put a new value in there, the old value is erased. That's true for all of the primitive types, and it's also true for the string. The string can only hold one value at a time. If you have string name equals enda, then it's enda until you change it. And if you put something else in there, enda is gone and now it became something else. So what if you needed to store more than one value that are related? And so here's the example. In this class, you're going to take some number of quizzes. And as you're taking the quizzes, you get a grade for each one of them. Well, if I wanted to store all of that information in a program, I would have to store a separate variable for quiz 1, and another one for quiz 2, and another one for quiz 3. And so I would end up with 10 variables, and that's just to store one student's information. If I needed to store all the information for all the students in the class, I would need hundreds, if not thousands, of variables. So that's kind of cumbersome. It would work, but it is difficult to deal with. And if we take that to a bigger example, or a more extreme example, think of the KSU registration system. There's about 43,000 students here at this point, and for each one, they have to keep track of the name and the KSU ID and the major, and probably lots of other things. All of that is related, so obviously one student's name and their KSU ID and their major is related because they're one student. But beyond that, they have to store a name for all 43,000 students, and a KSU ID for all 43,000 students. So if you think about doing this in code, you would end up with something crazy like string student 1, student 2, student 3, student 43,000, and so on and so forth. And that's, again, it's workable, but it's really not workable. It's just too much, and it's too difficult to deal with. So it would be great if we could put together all of a related set of data into a single structure. And that's where we come to arrays. They're used to hold multiple items in a single structure. Everything in the array must be the same data type, so that is one requirement of an array. You either make an array of integers, or an array of characters, or an array of strings, but inside of a single array, all that can be in it is the same type of data structure. So an array of integers can only hold integers, an array of characters can only hold characters, an array of strings can only hold strings. But of course you can have multiple arrays, just like you can have multiple ints or multiple floats. When you create the array, you're going to have to specify at the moment you create it how big you need the array. And that is one limiting factor of an array, and we'll see how to work with that as we go along. So I want you to think about an array as a book or a notebook. When you start off, when you buy a notebook in the store or the bookstore or wherever, you see that it has a bunch of pages. There's a set number of pages. You can't just add pages to it. It is defined at the time that you buy it as a 50-page notebook or a 100-page notebook or whatever it is that you bought. The pages are often numbered, especially in a book that you buy that already has text in it. Typically the pages are numbered, and they're not always exactly 1, 2, 3, 4, 5. Sometimes there's a title page and some acknowledgments and stuff like that that don't have numbers on them. But overall, each of the pages are numbered with a number from usually 1 to 150 or 300 or however many pages there might be. So a notebook effectively is a fixed size. Each individual page can hold some data, which in the case of a book is words or drawings or whatever it is that you're going to put in the book. The main way that they're different from arrays is that one rule of an array would be, if it was like a notebook, every page must have the same kind of data. If you put a number on the first page, then every page can only have numbers. So that's a little weird, but other than that, the analogy holds. It's a fixed number of pages, each page has a number, and each page can hold some data. And the type of data that you can put on the page, you get to specify that when you buy the notebook. Okay, so how do you actually create a notebook? Well, an array. The way that this is done is we're going to create an array that can hold 5 integers. So what I would write is int, and then I would specify some square brackets. All right, so this is the definition of an array of integers, and you're actually going to see that it appears here twice, once at the beginning and once at the end, and I'll explain the details of that as we go. The second thing that you're going to specify is the name of the variable. And in this particular case, I named my variable myArray. Just like with any variable that you create, you're welcome to name it whatever you want. And for example, down here you can see this is how you would have created a variable called x, which is of type int. Well, the same thing is happening up here. I'm creating an array of integers called myArray. So the first thing is the type, and the only thing that really changed here is the square brackets. The square brackets are what imply it is an array. So you put int square brackets, or if it's a character array, it'll be char square brackets, or if it's a Boolean array, it'll be bool square brackets, Boolean square brackets, or string square brackets, or whatever the type is that you want each cell to have. And then the name of the array, which in this case is myArray, is just a variable name. That's what I'm going to use later on. The weird part for arrays is that after you declare them, you also have to say equals new int, and then you specify a size over on the right-hand side. So again, this type could be different in new arrays. So you could have characters or bools or strings or anything that you want as the type here. It doesn't always have to be int. But whatever's on the left-hand side and whatever's on the right-hand side must match. So you can't say char square brackets myArray equals new int. That doesn't make any sense. It has to be the same on both sides. Okay, so effectively what I've done here with this definition is I have created a variable called myArray. I've told it that it is an array of integers that can hold 5 integers. So it's a structure where I can put 5 separate values in there. It's 5 because of that 5. If I changed that to 10, I would have been able to put 10 variables or 10 values into my array. But because I specified 5, I can only put 5 in there. All right. So next up, let's take a look at the different parts. So as I said, the first part is where you're going to specify the data type. So that must be immediately followed by a pair of square brackets. Those are 2 square brackets. It's an open square bracket and a closed square bracket, and those are usually on a key above your enter key on your keyboard. So it's immediately int square bracket square bracket. You don't put a number in the first one. That happens only in the second one. So notice that there is no number in that set of square brackets. Then you have a variable name, and as I say, you can call it anything you want. You're going to see in a lot of these slides I'm going to call it myArray, but you can absolutely call it Fred, Mary Jane, and it will work just without a problem. So you can call it anything you want, you just have to be creative with your variable names just like you always have. And then over on the right-hand side, this is what actually creates the new array, and it specifies its size. You'll always say the word new. You'll always then follow it with the same type that you had at the beginning, and then you will specify in the square brackets how big. And in this case, I'm asking for it to be of size 5. Bib, how big? There we go. Yeah, all right, we're just going to clear the screen because that didn't work out well. An array of 5 integers is, of course, a complex data type. And what that means is it's more like a string than it is like a int or a character. And it's simply because you can store more than one thing in it. And primitive types and basic types generally can only hold one thing. Okay, so what do we call each of these places that you can hold the values? Well, we tend to call them cells, array cells. Each array is divided into cells, and each cell can hold a single value. In the case of the array that I've just defined, each cell can hold a single integer. And this array that I've just created has 5 cells. So how would you go about picturing this? Well, generally when you picture an array, you're going to think of it in a straight line that is divided into a set of cells. Now, the weird part is that the cells are actually going to be numbered slightly differently than you would expect. And this is probably the most confusing part of the array topic. The first cell in an array is actually numbered 0. and the next cell is numbered 1, and then 2, and then 3, and then 4. The computer automatically does this for you. It's not like you can decide what you want to name your cells in the array. The first cell is always going to be cell 0, and then however many cells you have, they will be numbered up to that number. So I want you to notice that I created an array of size 5 here, and the highest cell value is going to be 4 because of the 0. The first cell, being 0, uses up a cell, or gives me a cell, but it is numbered 0. So that's probably going to be one of the most confusing things that you're going to run into with arrays. Having said that, each of these cells that we have allows me to store one value in it. So in cell 0, I can put a value, and in cell 1, I can put a different value, and so on. Each cell can only hold an integer because that's what I've specified this is an array of, but I can hold 5 integers in here, one in each of the cells. Okay, so I want you to think of each one of the cells in an array as if they were a separate variable. It's just that they have a weird name. So normally when I created a variable x, I would say int x. And then that's it. I can either assign a value to x or not assign a value to x. So I can say x is 7, x is 9, x is 3, but only one value is stored, whichever is the latest value. With the case of y, it works slightly differently. So once I create this int array of y, or int array called y of size 5, which can hold 5 integers, I have access to 5 different cells of y. I can put a value into y0, into y1, y2, y3, and y4, which are the 5 cells. So effectively, this created a variable that can hold one value. This kind of created 5 separate variables that are all squished together in a single thing called y. Y being the name of the variable, that's what I called it in this case, has 5 cells that can hold 5 different values. And so I want you to think of an array as if it has a bunch of separate little variables inside of it. All right, so how do we go about using it? Well, if I want to put a value into the cell 0 of an array, I would do it like this. I would say, first off, I created my array up above, and it's a new array of integers that can hold 5 integers. To put a value in the first cell, I simply say my array at position 0 is equal to, and then I specify the value that I want it to be equal to. Now I want you to notice that I used the array name, and then I followed it up with square brackets. And inside of those square brackets, I put the cell number that I wanted to put things in. It is not reasonable to say my array equals 20. That's not valid because my array is an array, and I can't assign 20 to an array that has 5 cells in it. You must always have the square brackets and a cell number that you want to actually put something into. Okay, so that's what's happening in all 5 of these statements. I'm putting the number 10 into cell 0, I'm putting the number 20 into cell 1, and so on, 30 into cell 2, 40 into cell 3, and 50 into cell 4. All right, so what does this look like when I'm done? Well, again, you're going to picture it as this long skinny box. Cell 0 has the number 10 in it. Cell 1 has the number 20 in it. 2 has a 30, and so on, and so on. Cell 4 has the number 50 in it. Okay, so if I wanted to get something out of an array, I can absolutely print it. Just like any other variable, I can say print my array at position 2. And so what's this going to print out? Well, it's going to look in position 2 of the array, and this is going to print out the number 30 because that's what's in cell 2. Now, I need you to be very careful to realize, and I've said this before, but I'll say it again, even though this is the third cell of the array, right? This was over here, this was the first cell of the array, this was the second, and this was the third. Even though it's the third cell of the array, the number that is being used is an index number for a cell. That index number is the number at the top. So don't think about it like it's the third cell. Think about it as if it's cell 2. There is also a cell 0, and that's what becomes confusing. So that's why I'm getting 30, not 20 out of this print statement. All right. So that's how you put stuff into an array. It's how you print stuff out of an array. And just to rehash this, cell 0 is the first cell. When we create the array of size 5, you would expect that you'd have cells 1, 2, 3, 4, 5, but that is not true. You do not have those cells. computers always index things from 0, so you actually have cells 0, 1, 2, 3, and 4. And this is really the most confusing part of arrays. It is probably the thing that you will struggle with the most, because very often you create an array of size 5, and then you try to put something into cell number 5, and you can't do that because there is no cell number 5. So very important to get that. I know I've said it a bunch, but we'll keep seeing it as we go. All right, so next up, just wanted to point out that arrays aren't always arrays of integers. You can absolutely have an array of characters. So this one holds 10 characters. You can have an array of booleans. This one holds 10 booleans. An array of longs. You can have an array of shorts, an array of bytes, an array of any of the types. You can even make arrays of strings. That's possible as well. And then the other thing to note is that they're not always going to be of size 10, even though I use that for all these examples. You can absolutely have little arrays like this one, which is of size 2, or really big arrays like this one, which is of size 1,000,000. So this declaration here creates 1,000,000 cells in an array that each can hold a floating point number. So that's a huge structure. I can put a lot of information in there. And all of it is known as my float array 2. So I just have that one variable name that I have to keep track of, and then it has 1,000,000 cells, which are numbered 0 through 999,999. All right, so when you declare an array, you're always going to declare the type of the array, and that's going to come first. Then you're going to have your square brackets. You're going to have a variable name, and then you're going to have new, the same type, and a size. This is the traditional definition. But there is actually a second way that you can create an array. And this is the definition to do it the other way. It's identical to the beginning. However, you don't specify a size in here, and instead you put a bunch of values into a set of curly braces after the fact. All right, so I'm going to show you an example of this, but it allows you to put values into the array at the time that you make it. And the example here is, you know that you can say int x, and then you can just put a semicolon. And that creates a variable x, but it doesn't have a value yet. In Java, it generally initializes it to 0, but you haven't put anything into x. You can also say int x equals 7, and that's valid. It creates the x, and it sets it equal to 7. So because there are two different ways to create a variable, one that doesn't initialize it and one that does, we have a similar thing going on here with the arrays. The first type that I've showed you doesn't initialize it, it just creates the array, and then it's up to you to do something to put all the values into all the cells. The second declaration type that I'm listing here actually sets all of the cell values for you. It's more akin to the int x equals 7 example than the just int x. Okay, as we mentioned, when you're using an array, you're just going to specify it as a variable name, followed by square brackets and the number that you want of the cell, and you can certainly assign values to it, which is what's happening on this line, or you can access values in it and print them out, which is what's happening in this line. The things you cannot do, you can't just try to assign a value to an entire array. That does not make any sense. This is bad. You cannot print an entire array. It does not know how to do that. You have to do something special to print them out. So you're never going to reference the entire array as itself. You're always going to reference the array with the square brackets. So every time you're typing the array name, you should be following it with square brackets. Okay, so here's our first challenge. We're going to write a program to ask the user for 10 quiz grades, and we're going to store the grades in an array of integers. And it says, hint, you may find it useful to use a loop. You'll find that arrays and loops go together a lot. And that's just because if you have 10 items in the array, rather than 10 times specifically asking and writing that in, it seems to make sense that you're going to use a loop that goes 10 times, asks them for a value, and puts it into the array. Okay, so we're going to take this one little bit at a time, and we're going to go ahead and code it. So the first thing that we were supposed to do was we were supposed to create an array that can hold quizzes. So it says, write a program to ask the user for 10 quiz grades. So I'm going to need an array of 10 quiz grades. It says that they are integers, so I guess our quizzes are always graded with integers. All right, so we're going to say int, square brackets, because I want an array of integers. I'm going to call this one quizzes, because, well, that's what it's holding. And then I'm going to say equals new int, and there are 10 quizzes that I want to store. So that creates for me an array with 10 integers in it. All right, and now I need to ask the user to enter in their grades. So that's going to be a print statement. I'm going to tell them enter a grade. And then I'm going to have to read in that grade, so we all know what's coming, which is I need a scanner. So I'm going to run up to the top, and I'm going to import scanner, Java util scanner. And down under here, I'm going to create a scanner. You can do this creation anywhere you want, as long as it's done before you get to using the scanner. So scanner myscan equals new scanner, and then system.in. All right, so we've created a scanner. We've created an array of integers, and we have asked them for one integer. I'm supposed to read in that integer, so I'm going to say int next quiz grade is equal to myscan dot next int. That's how you read in a number. Okay, so as this is written, it would read in one number. And if I wanted to put that in the first cell of the array, I would then say quizzes at position 0 is equal to next quiz grade. And that would certainly work, but if I wanted to do this 10 times, I would pretty much have to copy this 10 times and then paste it in a bunch, which is not what I want to do. So what I'm going to do is I'm going to use a loop, and the particular loop I'm going to use here is a for loop. You're going to find that a lot of times a for loop works really well with an array because you already know how big the array is and how many times you're going to go. So for int I equals 0, and then a semicolon, that's how we initialize a variable called I to 0. And then while I is less than 10, which means I can be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, but it cannot be 10 because 10 is not less than 10, I++. All right, so in here, I'm going to basically move these 3 lines down, and then I'm going to have to modify them ever so slightly. So that looks pretty good. That's going to ask them to enter a grade, and it's going to read in their grade, and I'm pretty happy with that. The only problem that I have right now is it's always going to put the grade in quizzes 0, which is not what I want. I want the first grade in quizzes 0, and I want the second grade in quizzes 1, and the third grade in quizzes 2. So how do I fix that? Well, I just need to change that 0 to I. I'm going to reuse the I variable that we're using in the loop so that each time through the loop, it's talking about 0, and then it's talking about 1, and then 2, and then 3, and then 4. So the I changes as we go through, and you can see that now all of a sudden, I don't have to write a huge amount of code here, but this is going to read in 10 numbers, and it's going to store them into the 10 cells of the array. It's not a very exciting program to run because it just asks for numbers, and then it does basically nothing with them. It just puts them in the array. So they got 100, they got a 90, they got 100, they got 100, they got a 90, 100, 90, 100, 100, and 100. And the program ends. But it did successfully do it. There's really no way for me to know it did it because I can't really see the array, but it did successfully do it. You're just going to have to take my word for it. You're going to see other examples here in a moment where we do other things and you can see the values inside the arrays. Okay, so this is a pretty common piece of code where you're going to create an array. You're then going to have a loop that goes over the array, and we call that iterating over the array. Iterating is what a loop does. Each time that it goes through the loop, that's one iteration. So we say it's iterating through the array, and it's filling values into each of the cells as it goes. And it's quite common that you're going to use the loop variable inside of the array square brackets in order to specify that you want to put it in cell 0, cell 1, cell 2, and so on and so forth. Okay, there's one other optimization that you can make here, and I'm just going to show you the code in the slide. So as always, I have the answer in the slide so that you can go back and reference it. And I did pretty much the same thing, but I consolidated 2 lines of code. This last line down here has 2 things going on in it. I read in from the scanner something called next grade or next quiz grade, and I stored that into a variable called next quiz grade. And then separately, I assigned to the array at position I next quiz grade. But you can actually consolidate those 2 things together. So this works identically to what I wrote. I just wanted to show you that it's possible. This is just a variable. And at the end of the day, you know you could have done this with a variable. If I had said int x equals myscan dot next int, you wouldn't have been surprised by that. You would have said, okay, that's no problem. He's reading in a number from the user and he's putting it in x. Well, the same thing is happening here. I'm reading in a number from the user and I'm putting it in quiz grades at position I. So it's just a shortcut to consolidate two things. But if this is confusing to you on the slides, then you can actually go back and look at the replet that I just did by rewinding the video. Okay, so if we talk about this loop for just a moment, the I was initially set to 0, and the condition on the loop is that I is less than 10. Okay, so to be clear, I starts off the loop as 0, and then the next time through it'll be 1, and then 2, and then 3, and that's because of this I++, right? 4, 5, 6, 7, 8, and 9. 9 is less than 0, or sorry, it's less than 10. So it will go through the loop the 9th time, which will read in the 9th value. But when I increments to 10, because of the I++, 10 is not less than 10, and it won't go through the loop that time. So therefore, it will never try to access quiz grades at position 10, which is a good thing because there is no quiz grades at position 10. Despite the fact that quiz grades was designed to have 10 cells, there is no cell 10. And again, that's the confusing part. The array was created up to size 10. That's what I did when I defined the array right there. And yet, inside of my loop, I'm only able to go up to 9 because they are cells 0, ... 9, not 0 to 10 or 1 to 10 or anything else. It's 0 to 9. All right, so very important. I know I'm saying that over and over again, but I promise you this is the mistake that you are going to make because it's the mistake that everybody makes. All right, so let's take a look at our next slide here. All right, so initializing the array. As I mentioned, there are two syntaxes for initializing the array. Choice number one is you can go through like I did in that last example, and you can create an array that's initially empty, but it has 5 cells, and then you can go through one at a time and set each of the cells to a value. And you can either do that one at a time, or you could use a loop to set all of them to 15 if that's what you were trying to do. The other alternative and the other syntax is this. So again, the first part of this syntax is identical. It's int square brackets my array equals new int. That didn't change. The differences are there is no size listed inside of the square brackets. And I specified a bunch of values in curly braces. Now, the fact that there's no size in there is because Java doesn't want you to say how many variables there are going to be in the array. You just give it all of the values. And once you tell it that there are, in this case, 5 values, you can see that there are 5 things inside of these curly braces, it understands that the array is of size 5. So it doesn't let you put a size into the square brackets because it'll calculate it for you. So basically, if you're initializing an array with a bunch of numbers in it, you just simply put curly braces after the declaration of the array before the semicolon, and you list out all of the different values that you want inside of that array. Each of those will be automatically put into the appropriate cell. So for example, 15 will be put into cell 0, 25 will be put into 1, 35 into 2, 45 into 3, and 55 into cell number 4. And again, those are the cells. It does this automatically. All right, so let's just take a look at that example over in our replit window here. So I'm going to leave that, and I'm going to create a new replit here, and we're going to initialize an array with some values in it. And again, I want you to remember that it is possible to have an array of integers. It is possible to have an array of characters or floats or anything else. They don't always have to be integers. So don't get stuck on the idea that they're always integers. So I'm going to do a couple of different examples here and just show you what they all look like. All right, so we're going to make an array of integers first as our first example. And I'm going to say int square brackets my grades equals new int square brackets, curly braces, 100, 90, 100, 100, 100, 90, 90, 90, close, and put out a semicolon. And then just to prove that that did something, what I'm going to do is in my print statement, I'm going to print out one of those cells. So let's say I want to see what's in my grades at position 3. Okay, so while that's compiling, I want you to think about that. This is position 0, 1, 2, 3. So I would expect that this will print out 100 whenever it's completed. And there it is, 100. And just to prove that point, because obviously I put 90s into a lot of them, I'm going to put an 80 into this cell just so it's different from all the other ones. 0, 1, 2, 3, 4, 5, 6. I'm going to print out cell 6 in this case. And now we should see 80. Okay, so the thing to notice here is you can specify optionally these curly braces with values inside of them at the time that you create the array. If you do that, you don't put a size in here, but it creates an array of the appropriate size with those values automatically in it. And again, just to prove that we don't always deal in integers, I'm going to say string square brackets, my words is equal to new string square brackets, and then I'm going to put in parentheses and teaches intro computing. Okay, what I've done here is I have created an array of strings, and I have put enda into the first cell, teaches into the second cell, intro into the third cell, and computing into the fourth. And again, just to prove the point, I'm going to go ahead and print out my words, at position 2, and that's going to be the word intro, 0, 1, 2. So we're going to get 80, and then we're going to get intro. Of course, we're also going to get a semicolon error, but 80 and intro. All right, so this is an array of strings, and that's a pretty common thing that you'll see as well, where you might want to store more than one string inside of an array. And to be 100% clear, each of these strings can be a full string. It doesn't have to just be one word. I can have as many words as I want inside of double quotes. The string is defined by one set of double quotes. That's how you make a string. So this is a string of an array of strings. And likewise, I can make an array of floats. And I can either initialize it or I can just create it and then later put stuff into it. And that's how I would put 15.2 into cell 0. So any type that you have seen up until now, you can make an array of it. Ints, floats, chars, bools, doubles, strings, and all of the other ones. All right, so here's the example that we just did. Int my array equals new int, and then there are 5 values in here. And if I wanted to add these values together, I might do something like int sum is equal to my array at position 0 plus my array at position 1 plus my array at position 2 plus my array at position 3 plus my array at position 4. And that's going to take the value out of cell 0, 1, 2, 3, 4, add them together, and give me a variable called sum. And so at the end of that, it prints out whatever's in the first cell followed by a plus sign, whatever's in the second cell followed by a plus sign, third cell, fourth cell, fifth cell is equal to, and then the sum. And if I were to take this code and I were to run it, it's going to print out the sum of all of these values, which that's about 175 maybe. So that's what this code would do, and that's how you access the individual cells and how you print them out, and all of that should work pretty well. If I go back over to my window, I might want to be able to take the grades and calculate an average of these grades. So how would I do that? Well, I would start off with a loop for int I equals 0, I less than, all right, how many cells do I have here? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 cells. They are numbered 0 through 7. I plus plus. All right, and so what I'm going to do is I'm going to set a sum variable equal to 0 before I start. So int sum is equal to 0. And then I'm going to add each of those numbers together. So I'm going to say sum plus equals my grades at position I. So as the loop runs, it's going to take the grades from the first cell and add them to the second cell and the third cell and the fourth, and put all of that into sum. And at the end of all of this, I can absolutely print out sum is plus sum. All right, and we're just going to run that real quick. We're still going to get, by the way, the other stuff from down below here, but sum is going to be equal to the sum of all those numbers, which comes out to apparently 750. And you can see that was really easy to write. All I had to do was specify I want to take the value from each one of the cells and add it on to the current sum. And since the sum started as 0 and the loop goes through all the cells in the array, bada bing, I get the answer to the sum of all of my numbers. All right, so in the earlier example, we read in 10 quiz grades, we put them into an array. How would we calculate the average quiz grade? Well, in order to calculate an average, you first have to calculate the sum. So this particular example is going back to where we asked the user to enter in 10 quiz grades. So I'm going to go back to that example, which was a different replet. So I'm just going to hit back here and hope that that brings me to the right place. Okay, so now that I found it, here is the original code where I read in 10 grades from the user and I stored them into the quiz grades. So to rehash, we created an array of size 10 called quizzes. We had a for loop that went from 0 to 10, where 0 is the first cell and 9 is the last cell because it says I less than 10. We asked the user to enter in a grade. We read in that grade and we stored that grade inside of the next cell of the array. And so right now this basically does nothing except ask for a whole bunch of grades, specifically 10 of them, and then the program ends. So what we're supposed to do is we're supposed to take this and we're supposed to add to it so that now it calculates what the average of those grades is. So after we've read in all of the numbers, I'm going to use another loop, and I'm going to do what I just did in the other replet a moment ago to add all the numbers together and get my sum. So I'm going to say int sum is equal to 0. You could call this anything. Sum is just a variable name, but I'm going to keep the sum in it, so it seems to make sense to call it sum. For int I equals 0, I less than 10, again because it's cells 0 through 9, I plus plus. All right, so what I want to do this time in the loop is I want to add each cell one at a time to the sum variable. So I'm going to say sum plus equals quizzes at position I. So the first time through the loop, it's going to take quizzes at position 0 and add it to the sum, and then the second time, and the third time, and the fourth time, and so on and so forth. So at the end of this loop, sum is equal to the sum of all the grades that the user entered. We know the user gave me 10 grades, so to calculate the average, I just need to take the sum and divide it by 10. And I'm going to have to specify 10f here because I do need it to come out as a floating point number. If I don't put that f, this is an integer and this is an integer, and therefore it will just give me integer math, which is not what I want. I want floating point math. So that f is important, otherwise you're going to get the wrong answer. And then I'm just going to print out your quiz average is, and then we're going to do plus average. Okay, so let's run it and do an example. All right, so this student is going to get a bunch of 70s, 80s, and 90s, and we're just going to alternate between the three as the program runs. So enter grade 70, that went in cell 0. 80 went in cell 1, 90 went in cell 2, 100 went in cell 3. And then 70 again is going to be in cell 4, 80, 90, 100, and we're going to have two more grades. So this time we got a 55 and a 20. It went really badly at the end of the semester. All right, I'm just going to move that window. It says my quiz average was a 75.5. And let's just think about that for a moment. It seems like the 70, 80, 90, and 100 would average to about 80 or 85, I guess. And so that should be about 85, but then these two would drag that down. So 75 seems plausible. So we've made a relatively useful program here. It reads in 10 numbers. It puts them into an array. We use the array to then calculate the sum and the average, and we tell the user what the average is. And you might say, well, is the array really necessary? Because I could have just read them in and added them to the sum and divided by 10, and you're right. But I think you could imagine that you might also want to be able to do other things beyond just tell them the average. For example, it might be interesting to know who had the highest or who had the lowest, or what was the standard deviation, what was the mean, the median, the mode, all those kinds of things might be interesting, and they could all be written on the array. So storing all the information in the array then allows you to come back and look at it again and figure out what you want to do. All right, so as usual, I do give you the code in here. And so in this particular case, I'm setting all of the numbers instead of reading them in a loop. And then I'm using that same loop to go through and add the sum together and calculate the average and print it out. So same idea, but in this case, I'm just hard coding the values in. In the case of the replet that's here, I am reading them in. If you want to play with this replit, remember you can pause the video and you can grab that URL, and if you type that into your browser, you'll be able to see this exact replit and you'll be able to modify it if you hit the fork button so that you can code it and play with it and see what's going on. All right, so we're going to go through a trace of this code as our last thing in today's lecture, and we're just going to see how this all works and how it looks in memory. So as usual, we start off with public static void main, and that's over here, and that's where we always start our program. So the first line is going to create an array of integers where the integers are pre-initialized to these particular values. It's calling the array myGrades, and so over in our variables, what you should picture is myGrades has this information in it. Each of the cells is pre-populated with 90, 80, 100, 100, 85, 92, and so on and so forth. Each cell can only hold one value. The first cell is cell number 0. The last cell is cell number 9. Okay, so that creates that and puts all the values in there. It's a lot of stuff that happened in just one line of code, but that is one line of code. All right, next off, we create a sum that's equal to 0, and then we're going to go into our loop. This creates an I that is right now equal to 0, and the way that the loop works is first time through, we create the I, and then we check, is the I less than 10? 0 is less than 10, so we're going to proceed. All right, so this line of code says, take myGrades at position I. Well, I is currently 0, so myGrades at position I is highlighted here in this red box. It is the value 90. And it says, add that to the sum variable. So the sum variable was initially 0, and we're adding 90 to it, so the sum variable is now equal to 90. And then we reach the bottom of the loop, and anytime we reach the bottom, it's going to send us back up to the top of the loop. When you get to the top of the loop, the very first thing that happens is the I++ happens, so I has become 1. 1 is still less than 10, so life is good, we're going to continue into the loop. All right, so now it says sum is plus equal myGrades at position I. Well, this time I is 1, so myGrades at position I is this red box. It's the cell 1, which is the value 80. And we're adding that to what was previously in sum. Well, sum was currently 90 when I started off, and now I'm adding 80 to it, so sum is now equal to 170. All right, we reach the bottom of the loop. It sends us back to the top. The I becomes 2. 2 is less than 10. So we go in and we're going to add to the sum variable. It was previously 170. And so we're going to add to that the value that's in myGrades at position 2, which is 100. So 170 plus 100 is 270. Reach the bottom of the loop, back up to the top. I became 3. 3 is still less than 10. And so we look at myGrades at position 3, which is another 100. And we add that onto the existing value of sum, and sum becomes 370. Bottom of the loop, back to the top, I becomes 4. 4 is less than 10. Add to the sum variable the value of myGrades position 4, which that's 85. So 370 plus 85 is 455. Bottom of the loop, back to the top, I becomes 5. 5 is less than 10, so we go in. Takes the value in myGrades at position 5, which is 92, and it adds it to the old 455 that was in there, and now sum is 547. Bottom of the loop, sends us back to the top. I is now 6, 6 is still less than 10. Sum gets added to another 100, because that's what's in myGrades at position 6. Sum is now equal to 647. Bottom of the loop, back to the top. I is now 7, 7 is still less than 10. We take whatever's in myGrades at position 7, which is the 75. We add that on to the 647, and sum is now equal to 722. Bottom of the loop, back to the top, I is now 8. 8 is less than 10. Add myGrades at position 8, which is the 82, onto the existing 722, and sum is now equal to 804. Bottom of the loop, back to the top, I is now equal to 9. Okay, 9 is still less than 10, so we're going to keep going. It's going to add the value of myGrades position 9, which is the 97, onto the existing value, which was 804, and so we get to 901. So sum is now equal to 901. Bottom of the loop, we go back to the top again, even though you know it's going to stop, but we are going to go back to the top. And at this point, I becomes 10, because that's what it incremented to. Now 10 is not less than 10, so therefore the loop ends. And when the loop ends, it just skips over past the closing curly brace, and brings us to the next line. So at this moment in time, sum is now 901 because it got changed as we were going through the loop each time by adding in each of the cells of the array. And so if we want to calculate the average, we take the sum, which is 901, and we divide it by 10 because there are 10 cells in this array. 5, 6, 7, 8, 9, 10. So each of these 10 cells has a value. We've added them together. We divide that number by 10, and that gives us an average. So the average at the end of this is 90.1, and then finally we print that out. I'd like to also point out that this is the variables that exist. My grade still exists because it's created at the beginning of main, and it'll be there until the end of main. Sum still exists because it was created up here. But I want you to notice that the I in this for loop, it went away as soon as I passed that closing curly brace. If I go back one step, the I is here as 10, but when I move forward, the I is gone, and now I have a new variable called average. And that is really how that works. The I is gone as soon as the loop is over, because it was only created inside of the for loop. And so therefore it's only there for the duration of the for loop. So double average equals sum divided by 10, and that gives me print out your quiz average is 90.1. And that is the end of that program. And so all the variables go away when we reach the end and the program terminates. And the only thing we're left with is the output of quiz average is 90.1. So that's today's lecture on arrays. We've covered a couple of things. We've covered how to declare an array, which is just type, square brackets, variable name equals new type square brackets with the size in there, or without a size, and then followed by the curly brace with values. We can have arrays of integers, floats, longs, doubles, shorts, booleans, characters, and even strings, and all of that is valid, and you've seen examples of those. And you can access an individual cell of an array as if it were a variable simply by specifying the array name followed by the square brackets and then putting a number inside of there. Because that number will often have to look at each one of the cells, it's common that we will use an I and use it inside of a loop, and that's why that is an I instead of the number 1. If it was the number 1, it would always add what's in cell 1, which is not what we want. And that's today's lecture. So that's arrays number 1. We're going to have 4 lectures on arrays. So we will pick up here in the next lecture in arrays number 2. I'll see you then.